Let's talk about the secret management, and this is one of the security aspect when you are working with the cloud or any on-premise infrastructure. And if you don't manage these kind of secrets which you store into your environment file, then you're potentially risking your whole infrastructure, whether you're working on a cloud or whether you're working on on-premise infrastructure. Now, when I'm talking about the secrets, so I'm talking about plain text secrets which you store into the environment file. And these environment files can be present on a Linux server where your applications are running. It can be present on any Windows server if you're hosting your services on a Windows server. And even those static text file or environment file containing the secret can be present onto your local development machine or as a part of your code, and which can potentially can be committed or pushed to the GitHub or Bitbucket repository where you're storing as a code and you're maintaining the versioning of your code. So once you push those kind of files into Bitbucket repository, then you're potentially risking those static credential and it is exposing to a wider audiences. Let me show you one environment file which contains a lot of plain text secrets. So here, this is an environment file which you can see on my screen. So it contains like a AWS credential, API keys, database username, password, ports, and also it contains JWT token. So it is just an idea that an environment file can contain a lot of information and a lot of like a secret value which you don't want to expose to any other person. And if you don't manage this environment file properly, then you are potentially risking your whole infrastructure and it can be vulnerable for external attacks. Alright, so now you have seen the environment file and what are the potential risks it can contain if you are not managing that credential file properly. And it is not about the environment file. If anything, any secret value which you are storing as a plain text, then it's a risk for you. Then what you need to do, you just need to find a mitigation plan and to reduce this kind of risk and potential attacks onto your infrastructure. All right, so what are the actions which we can take to improve the security of our secret? So the first rule of thumb is that don't store anything static or in a plain text. So that's the one thing. Secondly, if you still need to store something in a file, then try to encrypt that information so that it is not stored as a plain text and it is not a human readable. So that's the second thing. And the third thing, which is really good one, is don't store anything locally on server, neither on your local development machine. And that eliminates everything and which automatically improves your like a security 10 or 100 folds. So today we are going to talk about a tool called Pulumi ESC, and this tool can help us to potentially reduce the risk of storing those plain text secret into your environment or a properties file. And with the help of this tool, you can dynamically fetch those credential or secret values at a runtime whenever you need it. So if you're calling any external services, then you can easily supply those credentials at that particular point of time. You don't need to store those credentials locally or neither on a server. Let me jump to my screen and show you like how we can use and configure this Pulumi ESC tool to improve our security posture for managing our secrets. Alright, so before we set the Pulumi, it's really important for you to understand the scenario where I'm not using the Pulumi and how we can compromise my static credential. So the concept which I'll be explaining right now are applicable for any other cloud service provider, whether it's a Google Cloud, whether it's a Azure, whether it's a AWS. Alright, so I'm taking a very simple use case. So here, this is my laptop, and in the laptop, I am having a config file, which is my AWS config file. And in that config file, I'm storing the access key and the secret key, which are like a plain text and which are human readable. And it is stored onto my working laptop. So whenever I want to provision anything onto my AWS, or if I want to start like a virtual machine, Lambda, S3 bucket, then I need to use this access key and secret key. And in the middle, I'm using Terraform to provision those resources. So Terraform uses this credential, and using those credential, it connects to AWS and provision those resources on AWS. So here you can see that I'm relying on this static content which is present into my config file, and which can potentially increase the risk of compromising this config file which contains my access key and secret key. Alright, so I'm just taking the same flow, but now I'm using the Pulumi ESC along with the OpenID Connect to implement the same behavior, and we are not going to store anything into our config file. So here I'll start from the left hand side. So here you can see this is our source from where we will be fetching the access key, secret key, and a session token. And that session token is only valid for a limited time period. And to fetch those details, we need to use the OpenID, and these OpenID Connect, which we call it, it's just like an ID card which you need to show without revealing your password. So with that, what advantage we get over here is that you don't need to store anything locally onto your system. You just need to establish this OpenID Connect between the AWS and the Pulumi. And once you set up this OIDC or OpenID Connect, then you no longer need to provide any static credential. I'm just going to show like how to configure the OpenID Connect between AWS and Pulumi. But just for a moment, I'm just trying to make this flow and relate it with our previous flow where I'm using the static credential. So now we have a source, we have an OpenID Connect, and we have a Pulumi which is over here. And through this particular connection, we are just getting the access key, secret access key, and session token. And then we are gonna use our Terraform, and these Terraform will use those session tokens which are available from this particular OpenID Connect connection from Pulumi and AWS. And then we are just gonna provision the resources onto AWS. And with this particular flow, we are just eliminating storing any static credential or access key, secret key onto my local config file. Alright, so before we set up our OIDC OpenID Connect between AWS and Pulumi, the first thing which you need to do is you need to go and create a Pulumi account. So here, this is a sign up page where you can go and create your Pulumi account, or also you can use your GitHub or GitLab or Atlassian account to sign up for a Pulumi account. After the sign up, you will be taken to this particular Pulumi dashboard, and on the left hand side you will find a product which is Pulumi ESC, and if you click on this environment, then you can see all the environment, and these environments are just a segregation of your like a development, production, staging, and prod environment where you can manage your own secret specific to those environment. So for the current demo purpose, I have created this development environment, and you can easily create these environment. If you go back into environment once again over here, then if you click on this button, then you can create your own environment. So that's one thing which you need to keep in mind. So okay, so here is a development environment, and here in this development environment, you can see there are few secrets which I'm managing it from my Pulumi. But you don't need to worry at this point of a time about these secrets, which are pretty simple to manage it over here. You can just simply click on plus over here, and here you can just specify the path value, which is like a key value pair, and then you can specify the value, what value you want to store it inside your Pulumi ESC. And also you can specify whether it's going to be a plain text, whether it's going to be a secret, or whether it's going to be a provider config. So this is a very simple way to manage your secrets over here. And once you store those secrets in Pulumi ESC, then you don't need to store anywhere else. You can fetch those secrets from Pulumi ESC from this particular location. But anyway, this is just a very glimpse about this Pulumi ESC dashboard. But the key thing is we are interested, if I can jump back to this particular diagram, then we are interested in setting up the OpenID Connect between the AWS and our Pulumi ESC. So for that, we need a few key details from here. So if you go to the dashboard, then here you will see an organization. So you need to note down the name of your organization. Here you can see it is my own name, which is Rahul Wagh. So that name I will be using to set up my OpenID Connect. Now let's jump to my AWS console, and here I need to go to IAM over here. Go to IAM section, click on this IAM. And here you will find the identity provider, which you can see over here. So click on this identity provider over here. And here you can see there's already one identity provider which I have created. But if you're just getting started, then you can just click on this add identity provider over here. And here you need to choose the OpenID Connect. And once you click on this part, then here you need to provide a provider URL. And for that, there is a good documentation from a Pulumi which you can refer. I'll paste that a link into the description section to follow it. So here you can see all of those screenshot has been taken to explain like how you can set up your OpenID Connect. So here in the provider URL, you need to input this particular URL, go over here and set this URL over here. And then here you need to specify the audience. And in the audience section, you need to specify the organization name, which is this one, which is my name over here, Rahul Wagh. And if you follow the documentation, so here you will see that in the audience section, you need to prefix with AWS colon and then organization name, which is like this. So which you can see, I'm just going to copy this part from here and I'm just going to paste that one over here. And here you can just specify the organization name. And after that, you can click on add provider. All right. So this is how you can set up the OpenID Connect, but it's not only just setting up the OpenID Connect, you also need to set the permission and the trust policy. So here, if you follow the same instruction, then here you need to create a role, and in that role, you need to specify some permission, which I'm just going to show to you. Okay, so just follow these instructions, and after that, it will eventually lead you to the roles and the permissions, which you can see over here. So these are the permissions, which are just a normal IAM roles and permissions. Okay. So I can show you the roles and permission which I have configured. So this is the OpenID Connect, and if you click on add provider, then it will eventually lead to that particular IAM role and permissions. But anyway, I have already configured one of the role, so which I'm just going to show to you, which is this one. So Pulumi ESC Secrets Manager Read and Write. So this is the role which I have created with the permission. So here you can see in this, I have already assigned few permission like provision, for provisioning the EC2. So it has a full EC2 permission. It has a full S3 permission. And also it has a full permission to, or not full, but at least a read write permission to manage my secrets from Secrets Manager. And all of these permission you need to create at the time when you are setting up the OIDC connection. Okay. And here, this is the documentation for it. Just follow this instruction, which is pretty simple to set up this whole role and OIDC connect. All right, so after setting up the OIDC roles and permission, the next thing which you need to do is you need to install the Pulumi ESC CLI onto your machine or the developer machine if you're working on your laptop. So for that, what you need to do, I'll just jump to the documentation. So here is the installation link for Pulumi ESC CLI. So if you're using a Mac, then you can just simply use Brew. If you're using a Windows, then you can just simply download this particular installer file. And if you're using Linux, then you can just run this curl command, and which will help you to download the Pulumi ESC CLI onto your developer machine. Alright, so after installing the Pulumi CLI, you can verify the installation by running the command ESC version, and it will show you which version of your Pulumi ESC you have installed onto your local machine. So this is the version which I'm running at this point of a time after installing the Pulumi ESC. Alright, so now we have done all the one-time prerequisite setup which is needed for us to configure the Pulumi ESC. And now I'm just going to first show you if I don't use the Pulumi ESC CLI, and if I try to run my simple AWS CLI command, then it is going to complain that it is not able to find those credentials. So let me copy one command which is AWS STS get caller identity, which just tells you about your account which you are using to communicate with. So here you can see if I'm trying to execute this command, then it is just gonna fail. And here it is gonna tell me the problem that unable to locate your credential, and you can configure the credential by running the AWS configure command, which is okay, but I don't want to configure or store anything locally onto my laptop. So for that, like how we can use the Pulumi ESC. So here I'm just gonna copy one command from my notepad and paste it over here. And here you can see I'm just relying on the Pulumi ESC, which you can see this is ESC. I'm using the command run. Here I'm specifying the organization name, which is my name. Here this is the project where I'm working, and this is my environment, which is my development environment. And here I'm just supplying my AWS CLI command which I want to run. Okay, and here I'm just gonna hit enter, and eventually it is going to return me the account information, which is you can see over here. This is the user ID, this is the account, and this is the ARN. And this ARN is for the role which I'm using, which is the IAM role which I have just created when I did set up the OIDC for my Pulumi ESC. So here you can see like this is how I'm just gonna use the AWS CLI without storing those credentials onto my local config file. Alright, so now we have completed this part where we have set up the OIDC connectivity, and we have run few AWS CLI command with the help of ESC CLI to verify the connectivity. The next thing is I'm just going to walk you through my Terraform project, which will provision the resources onto our AWS cloud. And we are just going to provision very simple resources, for example, EC2, VPC, and subnet. Here is my EC2 or VPC subnet provisioning project, which you can see. If needed, I can paste the link of this GitHub repository into the description section. But here is a quick walkthrough. So here is my main.tf file, and this main.tf file is responsible for provisioning the networking, which will create a VPC subnet, route table, internet gateway, and here it will also create security group, and at last it is going to create few EC2 instances. And all of those modules are written over here, which you can see. This is the module for EC2, this is the module for networking, which will create a VPC subnet, private subnet, public subnet, route table, and internet gateway. And this is the module for a security group. So this is a very simple Terraform project which I would like to provision with our Pulumi ESC using my Terraform CLI. Let's try to run the Terraform command without using the Pulumi ESC so that we don't provide any credential to our Terraform CLI. And also I'm not storing anything locally onto my development laptop. So ideally this command should fail whenever I'm executing, because it is looking out for some credential to authenticate against the AWS. So here is my first command, which is terraform init, and as soon as I'm just going to execute this command, then it is going to complain for the credential sources. So here you can see the no valid credential sources found, which means it is not able to locate the AWS credentials to provision the resources like EC2, VPC, subnet, route table, security group. So none of those will be provisioned. Alright, so how the Pulumi ESC is gonna help over here? So for that, I'm just gonna run the Pulumi ESC command along with the Terraform CLI. So let me clear the screen. And here is my command for my Pulumi ESC along with the Terraform CLI. So let me explain this command to you. So this is the ESC run which you need to put. And after that, you need to supply the organization ID. Then after that, you need to specify the project. And after that, you need to specify the environment, which is my development environment. Followed by the -i, which is interactive mode. If user want to input something from the command line, then we need to provide this -i flag in the command line. And after that, your original command of terraform init, plan, or apply. So first we are going to begin with the terraform init command. Just hit enter over here. And it will not ask for any kind of a credential, or it will not ask for any complaint that, hey, your credentials are not found. So here you can see the Terraform has been successfully initialized, and which you can see that over here, this is the command which we have executed, and Pulumi ESC has successfully supplied those credentials to the Terraform init, and those credentials are dynamic credential, which are short-lived credential. Alright, so now my Terraform has been initialized. The next thing I'm just going to do, I'm just going to let me clear this screen. The next command I'm just going to run is Terraform plan. So here, if I go over here and just change the command from Terraform init to Terraform plan, and then it is just going to show me that how many resources it is going to provision or planning to create when I'm executing this command. So here you can see that it is planning to add 21 resources. Next thing, I'm just going to clear the screen, and the final command which I'm just going to run is Terraform apply over here. And this Terraform apply command will take a few minutes to execute it. So I'll be back once this Terraform apply command has just finished. So it is asking that, do you really want to provision those resources? So I'm just going to type yes, and then I'll just wait and I'll come back when this resources has been provisioned. And as you can see, there are 21 resources which got provisioned, and these resources are not only one type of resources, but it includes VPC, subnet, route table, then security group, and then EC2 instances. So let me show you all of those resources which got provisioned. So here is my AWS console, and in this AWS console, if I look for VPC, so just click on VPC and go over here. And here click on the VPC, and here this is the VPC which I have created, which is a dev project EU Central VPC 1. And similarly on the subnet, you will find all the subnets over here. So I'm just going to remove all of the filter, and from here I'm just going to choose the VPC which I have created. So here you can see the subnet, and along with that there are a few route tables also. So here is my private route table, here is my public route table. Along with that, I have also created some EC2 instances, which you can see there is a one EC2 instance running. If you click on this EC2 instance, so this is the name of my EC2 instance. So this is just a demo purpose. So I'm just using Ubuntu Linux EC2 as a name for my EC2 instance. And if you click on this instance ID, then here you can verify it is running into the same VPC, which you can see. So this is how you can just like dynamically provide your credential, and then you can execute the Terraform command, and then you can just provision n number of resources onto your cloud. Right now I'm using AWS, but you can use the other cloud options as well, and there also you can provision multiple number of resources which you want for your project. If you really like these kind of a content where I just walk you through these kind of a tools which are really essential to manage and improve your security, then please put down into the comment section. And also if you really want to see some kind of a more real-time project with these secrets management tools, then also please mention into the comment section, and I'll try to prepare those projects for you as well. So I hope you're enjoying these kind of sessions, and if you have any feedback, then please leave that into the comment section, and please check out this tool which you can easily do the sign up and which you can play around with it. And yeah, see you into the next session of this sort of topic or another topic on Pulumi. Till then, take care and bye bye.